we're now going to look at the creation of the crusher lubrication control. Crusher lubrication, right? Okay. So we're going to start from the left side and then work ourselves towards the right. So you notice that for the most part, a lot of these are just control relays, which is basically used in logic configuration as opposed to being actual power contactor related, okay? Which is just to say that you'd find that things like 3BG6 is purely a control relay. The coil belongs to a control relay as opposed to 4DC1, which is a power contactor coil, okay? So we're going to start from the left side going to the right side. So you notice that at the top upper, the 110 volts control bus, which is just to say whatever control we have in here is 110 volts. We can even use 120 in our case, which is what we're working with. So we go down here. In the first rung, you notice that they are just basically just switches, okay? So we've got the emergency stop push button, emergency stop push button, emergency stop push button, emergency stop. So you've got like 4 stations with emergency push buttons, okay? So we'll come under switches, okay? We need to look for emergency push button. Okay, no, not this one. Push button, automatic return. Okay, so we might as well just collect them, okay? Push button with make contact, break contact, and this one here. This one is what? It's push button, mushroom, emergency stop, break contact. Okay, so we need this one here. And according to our schematic, we need 4 of these. So 1, 2, 3, and 4. Okay, so we can just maybe change the orientation, like transformation, rotate left, okay, like so. And then of course I need to create 4 copies of these, okay? So second, third, and fourth, okay, like so. So these are the 4 emergency push buttons, right? And then of course NDR is I think this is related to the hydro set, which is basically in the hydro set circuit. It's related to HDR, okay? It's basically a normally open contact associated with the hydro set, okay? So that's what HDR is. This is actually HDR in this position. So we're going to say, as opposed to writing this, we're just going to say emergency stop station 1, emergency stop station 2, emergency stop station 3, and station 4, right? So we come here. Do we need to check what the control voltage is? Okay, these are rated for contact. Rated making capacity is that the operational voltage is 600 volts. It's overkill, but I don't really think there's any harm with this. We can just leave it as is, or we can change this to 120 if we wanted, okay? Okay. Operational voltage, we can change this to 120. Okay, I'm not going to change anything. Current, it's not significant in this particular case, but I don't really want to come to each of these and start changing things. So I might as well just copy the same one. Okay, so just as well copy the same one so that we don't have to be going back and forth. We change the properties with 1, then copy that one with this modified values. Okay, so rated contact rated operational voltage is 120, which is what we want because the control voltage is 120. Okay, so coming in here, we say builder item identifier which is right here, item identifier. So this becomes station 1 emergency. Okay, and then I'm going to copy this, go to the second one, and then this is going to be station 2. Okay, then we go to station 3. This is going to be station 3, and then this other one is going to be station 4. Okay, this is going to be station 4 emergency. Okay, we know these are emergency push button, but I'm just going to call them emergency. Okay, so now this is what we have. So we have declared station 1 emergency stop push button, station 2, station 3, and station 4, right? The only other thing we do not have at the moment is HDR. Now HDR is associated with the hydro set, okay, which is a control relay, right? So what we can do is we can introduce a relay coil which is AC, right? Which is AC like so. And this one here, we're going to do two things first. Okay, we're going to change this designation to HDR, okay, which is hydro set. Okay, according to this schematic, I'm not changing any particular thing. And then in the builder, for now, I just need to create one normally open auxiliary contact. Okay, so which is normally open, and then just say okay. Ideally, what we're just saying is that this coil HDR as a control relay it belongs to a relay of which this normally open contact is a part of. It's an auxiliary contact of the relay in which you get to find this coil. Okay, so this one here gets to come in this position, and then transformation, rotate left, okay, like so. And then I'm going to put this one in this position. Okay, so we have all the elements in the first rung. Okay, we have all the elements apart from this coil designation 3BD6. So again, we need an output coil designation 3BD6. Okay, so this one here is going to be 3BD6. Okay, internal item ID is 3BD6. I'm just going to use 3BD6, and then we may want to check the corporation of voltage. I think this is just 120. Okay, it's exactly 120. And then transformation, rotate left. Okay, so that's what we get. We get to put it down here in this position. Okay, so this is what we get to have. So let's see, can I push this up here and then select everything? Okay, and then distribute transformation, can I say middle? Okay, it works out for these, but okay, distribute vertically. Okay, so but I would want to move this down a bit like so. Okay, and I would also want to do the same thing for the coil. Okay, so this is our 3BD6. We can even put it in a similar position like so. So this is our 3BD6, but across the two ends, okay, we can interlink these and interlink all of them. Okay, we can interlink each and every one of these. Okay, so we can have it like so. So let's see, why can't you seem to and I zoom in more. Okay, I think this is not bad. So that's our 3BD6. But across the two ends, we need a supply. Okay, so we're going to add like we're going to add input links. Okay, we're going to add input links. So we come to where it says links, input, NEMA. Okay, we need this one. And then transformation, rotate left. Then this link, input link, I'm going to associate to N1. Okay, I'm going to associate to N1. Then of course I'm going to call this as N1, just so I remind myself that of your tuchitile. Ain twalachita so, and then this one here will be linked to this point. And then on this other end, okay, you know what mistake I've made, so at least I've realized. Okay, I'll need L1. I need L1. So this is going to be item identifiers L1. Okay, what we're going to do is okay, this is like L1, right? So I'm going to just swap the two positions for the live and the neutral. Okay, I'm not really doing anything out of the ordinary. I'm just swapping these. Okay, so we'll get the live end. So this one comes here, and then of course this is our neutral end. Okay, so we have the first rung configured. Okay, so what we have is the first rung where there's actually like 3BD6. Okay, and then the reason why I've just chosen to call this as station 1, station 2, station 3, station 4 EMR, these are just emergency push patterns. If you look at these, you notice that at this point they're saying that this emergency stop push pattern is located at the hydroset station. Okay, and then this one at the crusher, and then I suspect the first position emergency push button and the second one, these must belong to the vibrator 1 and then the vibrator 2, the two separate positions. Okay, and then let's see, in which case they needed to be 5. There's the lubrication pump station. Okay, because the hydroset station is basically located where the lubrication system is. Okay, these are like in the same vicinity. They share they more or less share panels. Okay, so when you go to the lubrication station, that's where you're going to find the hydroset pumps, the hydroset pump station. Okay, at hydroset loop pump. Okay, so basically that's why it's like this. But for these other ones, the crusher emergency stop push button is separate, and then so is the vibrator 1 and vibrator 2 emergency push buttons. So these are the different stations. Okay, and then in the next rung, we're going to have something like 3BD1, but along the way we have associative contacts. I'm calling them associative contacts because they belong to coils. Okay, so if we have 3BD5, then at some point we should have 3BD5 coil. Okay, this is an auxiliary contact of 3BD5 control relay. So here I'm going to rename this to I'm going to name this as 3BD5. Okay, so this is 3, this is going to be 3BD5. Okay, and then in the builder we need a normally open contact, okay? And of course the voltage should be 120, but it's 600, but it's adequate, so we won't change anything there. We just say okay. So now that we have 3BD5, we need the auxiliary contact. So this one here, transformation, rotate left, and then we'll bring it here, okay? So this is our 3BD5, okay? So this is our 3BD5. Do we have the port names locked? So I need to maybe do this, okay? So this is our 3BD5, and then we have 283. So if there's 283 as an auxiliary contact, there should be 283 as a control relay, okay? So what I mean is we need to, at some point there should be 283, maybe in the crusher circuit, the crusher main drive. Let's look for, so this is 283 as a control relay, right? And then so the only thing we're going to do is on 283 we're going to create the control relay, right, which we're going to call as 283, right? We're going to call this as 283, and then 283 is going to have a normally open auxiliary contact, okay, associated with it. So that's what we have, okay? So this right here is 283. We've got our 283, and then of course there's 3BD3, 3BD4, so we might as well do this at the same time, okay? So the same reasoning, if there's an auxiliary contact, there should be a coil, okay? So this is going to be 3BD3, okay? This is going to be 3BD3 with an associated normally open contact, okay? So 3BD3 is here, okay? And then thereafter we expect to have 3BD4, okay? So this is 3BD4. Again, we're going to do the same thing, copy, and then readjust the identifier to 3BD4, okay? Item identifier is going to be 3BD4, and then we need to have a normally open auxiliary contact, okay, like so. So 3BD4, 3BD6 is already associated, okay? 3BD6, then 4DD1. 4DD1 is what? It's supposed to be to the right. So 4DD1 is a 4th strip control relay, okay? So 4DD1 we do the same thing, okay? Copy that coil, retag to 4DD1, to 4DD1, tag this as 4DD1. Then of course we need a normally open auxiliary contact, okay? That's what we need. And then 4DD1 is taken care of, and then we're talking about a push button, a stop push button. So under switches we need a push button switch with a break contact automatic return. So we need this one here, and then this one will be designated as system stop, Okay, builder. So this is going to be the system stop. Okay, this is going to be the system stop. What voltage is this rated for? Let's see. Adequate. I'm not changing, I'll just leave it as default. So this is going to be our system stop. Then we'll need 3BD1, so we're going to copy this, and designation will be 3BD1, right? So this is going to be 3BD1 with an associated normally open contact. Okay, associated normally open contact, like so. So we are system start. Okay, we can just get a push button switch with make contact automatic return, and then this one here is going to be our system start. Okay, this right here is going to be our system. It's going to be our system start. It's going to be our system start, and then builder. The voltage for this contact is what? I think it's 600, so we don't have to change it. It's not necessary for what we're doing. Okay, and then in this run we just we need another coil. This is a timer. Okay, it's but what kind of timer is this? So when the system is starting, the sequence control relay is energized. So 3BD1 is a sequence control relay, is energized. Can we add comments to 3BD1? So can we add a comment? Component location, component type, comment. So comment display value. Okay. Can I say sequence? Is it really the right position for me to say this? So sequence control relay. Okay. Display alias, display value. Okay, so display alias. So display value. What am I seeing? Okay, let's see. So sequence control relay. Comment sequence control relay. Display alias. Okay. So just cancel the display alias bit. Okay. So 3BD1 is a sequence control relay. So you can actually, this is actually a thing. Okay. So this is actually a thing, that 3BD1 is a sequence control relay. I guess we can do the same thing with 3BD6. Comment. Okay. And then this is actually a safety relay. Okay. This is a safety relay. So let's see. This is a safety relay. So 3BD6 is a safety relay, like so. Okay. That's what we have. Safety relay, sequence control relay. Okay, and maybe do it like this. And then in the 3BD1, we're saying that 3BD1 is a sequence control relay. Okay, so maybe I would want to put this on the, just here, just in this position. Then transformation, rotate left. Need this down here. Then I'll need this coil right about there. Okay. Okay, so the only thing we need to do now is look for, the only thing missing is 4DD2. Okay, and then of course we're talking about 3BD2, as in asking the kind of timer that 3BD2 is. So when the sequence control relay is energized, it's energized at the same time as the loop control timer. So this is 3BD2, which is used in position 10. Okay, so 3BD2 is used in this position. So it's basically an on delay timer. Okay, so 3BD2 is an on delay timer. So this is an on delay timer. Then what kind of timer is 4DD2? So 4DD2 main drive delay timer. So both of these are delay timers. Okay, so let's see. Contactor coils, relay coils should be under relay coils. Relay coil of alternating current, no. Relay coil of slow operating, slow releasing relay. Relay coil of slow releasing. Relay coil of a slow releasing relay. Okay, no. Relay coil of a slow operating relay. So most likely need this one with an on delay effect. Okay, so one of these is going to be 4DD2, the other one will be 3BD2. Okay, now just to help you understand what it is I'm trying to say here. Okay, so I'm going to assume this is like 3BD2, right? So I'm going to relabel this to 3BD2. Okay, I'm going to say 3BD2. I need all caps. Okay, I'm going to name this as 3BD2. The coil should be 120. Okay, labeled control voltage is 120, which we have no problem with. And then I'm going to get a normally open auxiliary contact. Okay, so I'm going to get a normally open auxiliary contact of 3BD2. Okay, this is the builder, the coil. Okay, so let's see. Delay on operate. Okay, so delay on operate. I'm just going to go for 10 seconds. Okay, we're just simulating this. The only other interesting bit is the control voltage, rated control voltage. Okay, rated control voltage 120, and then the delay to operate, the delay time. Okay, then the maximum delay on operate, still also 10 milliseconds. The delay on operate, then the maximum operating voltage factor. Okay, I don't really think we need to change anything else, so we're going to accept this. Okay, and then just to show what this is. Okay, so I'm going to do this, then I'm going to transform this. Okay, transformation, rotate left. So this is our 3BD2. Okay, with a preset value of 10 seconds. The associated contact is this one here. The only thing I'm going to do is I'm going to borrow this push pattern. Okay, and then I'm going to insert it in this position. Okay, this is just so for illustration, so that you know how this particular section is going to work. Okay, so that we're together from the get-go. Okay, here, then we're going to just jump this. Okay, so our key focus, even though we don't see the whole picture, but our key focus is on the relationship between 3BD2 and this associated normally open contact. Okay, so we're going to go into simulate, and then we're kind of just going to close this. Okay, not that, we need to. Okay, so this is closed, but I bet the power circuit is closed. Okay, or maybe instead of us going back and forth every other time, so maybe we can do the same thing with this one here. Okay, so on simulation, closed on simulation. Okay, so we've learned that the value should be true, okay, so that we don't really start going back and forth every time to normalize the operational state. Okay, so let's do that again. So let's see that again. Okay, so this is live now. Okay, now our interest was on the behavior of 3BD2 in relation to its normally open auxiliary contact. So we close this. Okay, we close this. You notice that this doesn't change state. Okay, so I take it this is maybe 4, 5, 6, 7, 8, 9, and 10. Okay, right about now. Okay, so essentially, I don't know where the delay is coming from, but this is like 20 seconds later, it actually just closes. Okay. Anyhow, so let's see. If I did this at 5 seconds, okay. No, it's like it's twice whatever I've set it up for. So let me try 5. I don't know if it's just my software acting up or maybe. So I expect to have maybe like a 10-second delay. Okay. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, about 13. Anyway, but the whole point is this particular contact provides an on delay effect. So let's get rid of this, and then let's get rid of that. So now we have 3BD, we have 3BD2, and then the same way, even 4DD2 is an on delay timer. So we're going to create this coil, copy the coil, and then this is going to be 4DD2. Is it 4DD2? Yes, 4DD2. So this one here is going to have 4DD2, like so. And then of course we need an associated normally open contact, okay, which is normally open. Is it normally open? No, it's supposed to be normally closed. Normally closed. This one here, okay, like that. So now we've got everything needed to do rung number 2, okay, in rung position 4, okay, rather. So the only thing we need to do is move from 3BD5, okay, which is what we already have. So I've got 3BD5, then we've got 283. So I've got 283. So transformation, rotate left. So this is our 283, and then we need 3BD3. So 3BD3, where are you hiding? So this is our 3BD3. Transformation, rotate left. Then we have 3BD4, which is this one here. So let's put it down here. Transformation, rotate left. And then we have 3BD6. 3BD6 just needs to give us an associated normally open contact, okay, normally open contact. So we have 3BD6, and then we have 4DD1, which is this one here. So transformation, rotate left. Okay, so this right here is our 4DD1, and then we've got the system stop, should be this one here. Okay, transformation, rotate left as our system stop. Then system start and whatnot. So I may want to move these up to create more space. Okay, so we've got 3BD5, we've got 283, we've got 3BD3, we've got 3BD4, across from which there's 4DD2. So across from which there's 4DD2. Okay. Transformation, rotate left. So we're saying across from 3BD4, there's 4DD2. Okay. So it's this arrangement. Then 3BD6. Oh, right after that, there's 3BD6. So there's 3BD6. Okay. Transformation, rotate left, which is what we're saying as 3BD6. And then 3BD6, there's 4DD1. 4DD1, there's system stop, then system start. Across from system start, there's 3BD1. So this 3BD1 comes here. Okay. So the only thing I need to do is I need to get all of this and then just say distribute vertically. Okay, so that I arrange them properly. Okay, so this one here moves in that position. So this coil goes to the left. We don't need it now. So all we need to do now is make the connections. Okay, then this linking business. Okay, 283. What was the normal state of 283? 283, what's your normal state? The normal state of 283 is what? Is de-energized, okay? Because 283 is only energized under fault conditions, which is why in network 4 or rank 4 it's used as normally closed. Okay, so in this run 283 is used as normally closed, so maybe this we need to change to normally closed. Okay, so 3BD5, then 3BD5, the normal state of 3BD5 is what? So it's saying that it's called a loop oil flow interlock. So this is more like a reset for DD2 when 3BD5 is energized. 3BD5 is only energized if 3BD4 has not been energized. So basically when there's no flow, because this 3BD4 is a consequence of having flow, so flow switch 1, flow switch 2 will energize 3BD4. So when 3BD4 is energized, this one opens, 3BD4 opens, and then 3BD5 is not supposed to be energized. Okay, so I also assume that in this position 3BD5 should be normally closed, because when 3BD5 is energized, it shows you that there's no flow in the system. Okay, so 3BD5 normally closed, because also they are saying that 3BD5, nothing is said about 3BD5, but in this position I'm saying it's used as normally closed. So 3BD5 is a lubrication oil flow interlock relay. So when 3BD5 is energized, it means that your system has no flow, but the system is in the run state. So this one will be energized and your system will trip. So 3BD5 normally closed, 283 normally closed. 3BD3 is what? So 3BD3 is a loop oil flow, is a loop oil temperature switch. So we're going to assume that under normal conditions 3BD3 is supposed to be constantly energized. So in this position 3BD3 is supposed to be normally open, so that when this control relay is energized, its normally open auxiliary contact will close in this position. Okay, so link, and then 3BD4 is a flow control relay. Okay, so flow switch 1 closes, flow switch 2 closes, then 3BD4 is energized. So if 3BD4 is supposed to be energized when there's a flow in the system, okay, so in this position it's normally open, so close that. 3BD6 is a safety relay, safety control relay, which is here, safety relay. 3BD6 is constantly energized, so in this position it's normally open. Then we come down to 4DD1. 4DD1, what are you about? So 4DD1 should be in the loop control circuit. Okay, so 4DD1 again is only energized under fault conditions, because you notice that upper natukwate 4DE3, which is thermal overload, 4DE2 earth fault relay protection. So this is only energized under fault conditions. So 4DD1 normally open in this position. Okay, so link, and then link the start and the stop push button, then linked to the targeted control relay, and then across the start, like we said previously, we need the seal in contact. Okay, need a seal in contact. Then additionally, across from 3BD1, there was 3BD2. Okay, so we need to get the 3BD2 coil. Okay, so get this one here, connect it across from 3BD1. Okay, and then this one is called the lubrication control timer. So we can go in data and then comment loop control. This is going to be the loop control timer according to the description. Okay, I'm going to do what is it showing? Okay, display alias. So this right here is our loop control timer. Can I just delete this particular one? Okay, so I've got the loop control timer and across from 3BD1 then maybe this one, these two, I need to align bottom. Okay, then I need to connect this across. Okay, I can do whatever I want, so I can even put it there or I can put it here. Okay, this is pretty much the same thing. Okay, so now that this is done, we've got a complete path from equivalent of this. Okay. Okay, we've got our lubrication control timer. Okay, we've got our safety relay, we've got our sequence control relay, we've got our loop control timer. Okay, and then thereafter we need a control relay, alarm control relay. Okay, this is basically just for alarm purposes. So alarm control relay RR. This is basically just going to be a normal control relay. Okay, so this is going to be RR. Yeah, item identifier. This is going to be RR, and then this is going to be alarm control relay. Okay, so we have that, which is in this position, right? So let's move it a little bit to the left. But this one's hogging up all the space. Okay, maybe like this. So this relay is the alarm 2 control relay, because there's one in the remote station, one in the local station. So maybe, so we can just maybe say remote station alarm control relay. Okay, no, maybe, or maybe I can, in this particular case, take the liberty and just transform left and then maybe put it here. Okay, because this description is for this. So remote station alarm control relay. Then of course we're going to have the local station. So we're going to have the local station alarm control relay. Okay, we're going to have the local station alarm control relay, which is now this one here. And then moving on to the right, I know these cores are just being obstructions, okay, because we don't really need them as just yet. Okay, so let's get this off. And then of course across from 3BD4 there's 4DD2, so in case we end up forgetting. Okay, so we have finished this this particular rung in networks. In rung 4 and 5 we're done with these ones. Okay, and so the only thing we need to worry about is rung 6 and 7, which we've already started working on. So the only control points is 3BD1. So 3BD1 is expected to give us a normally open contact. Okay, we'll create another group, so which is normally open. Okay, I know it's normally open because when the sequence control relay is energized, right? When the sequence control relay 3BD1 is energized, that's when the alarms are supposed to come on. So transformation, rotate left, and then we're going to put this one right about here. And then of course 281, did we create a coil 281? 281, we don't have a control relay 281, but we can create 281. Let me just make sure first. Okay, we can create another coil, designation 281, but what's the normal state for 281? It's on the crusher. Okay, so 281 is the main drive control coil for that power contactor for the main drive. So 281 is a power contactor. Okay, so maybe contactor coil. Okay, this one here, and then this one is going to be identified as 281. Okay, This is going to be 281. It's going to be identified as, I need all caps for 281. I need all caps for 281. And then if this is 281, we need an associated normally closed contact, okay? And then I guess you're asking, but why does it have to be a normally closed contact? I got you, okay? So we go to 281 and this associated normally closed contact, okay? If you look at this for the local and remote station alarms, okay? So we've got the local station alarm, or rather the remote station alarm, the local station alarm. These two alarms are energized at the point where the sequence control relay 3BD1 is being energized, right? So when 3BD1 is energized, these closes and the alarms start to ring or to alarm the situation, okay? But if they're able to start during the sequence control relay, 281 is the main drive control relay. So 281 is the main drive control. This is now, you can think of this as a control relay, or you can think of it as the coil for the power contactor, which we're thinking it is in this case, okay? So when this power contactor for which 281 is a part of is energized, this auxiliary contact is now the one to de-energize the alarms, okay? So which is where 281 comes into play as in this position as being normally closed. So that's our 281, okay? So transformation, rotate left. So this is 281. So this is 281. So if we need 3BD1, and then we also need 281. So let's spread them out. We've got too much space in this run here. The port names are not locked, so we may want to are the connection port names locked. So we may need to do this. Port names for each one of these, okay? I was thinking once you unlock the connection port names is for everything, but apparently not. So this is what we have, okay? So 3BD1, 281, 3BD1, 281, then the control relays for the local and remote station alarms. So these, maybe this one, and this one. So we need to align in the middle, okay? So that now we just do the connections, okay? And then on this end we just need to do this, and then on this other end we just need to loop these. So maybe this one and these ones I need to align at the bottom align, okay? Then of course there's this parallel connection right after 281, okay? So we can just borrow this, do that, and then these two rungs are basically done. So rung 6 and 7 are done, okay? So now that we have this, you notice that on this document, right, we move on to where it says the crusher lubrication control is like extends all the way to the right, okay? So at this point we're talking about the actual control of the lubrication station. You notice that the first thing we're talking about is the main circuit breaker auxiliary control, designation MC AUX, okay? So in this particular regard, what we're just trying to say is, remember when we were doing the power circuit, Okay, when we're doing the power circuit, we introduced this amazing little guy. Okay, we introduced this breaker, right? So for intensive purposes, this is the breaker. Okay, so do we do comments? Okay, data tripping comments. Apparently for this one we don't have the ability, but the whole point is this main circuit breaker. This is the MC. Okay, main breaker. If you want, you can call this as MC. Okay, as MC. We call this as the main breaker, but you can also call it as MC. Now that we're realigning the schematics, okay, so if this is our MC, we're saying we need an associated normally open contact. Okay, so we just say okay, and then we're going to close this. So now we have this is what we have. Okay, so this is our MC auxiliary. Okay, now seeing as how we know that this is our MC auxiliary, we just need this auxiliary contact onto the control. Okay, so we just need this one here. We need this auxiliary contact. Okay, we need this particular one. We need this particular contact here. Okay, so that you know where it's coming from. So after MC, we've got 4DE3, and then we've got 3BD5, 4DD1. Okay, so we can just check on we already have 4DD1 declared, right? So we can just generate a contact, okay, which is like normally which is normally open, is it? Yes, so which is normally open. That's 4DD1. Okay, because I'm working myself from the live end. So we've got the main circuit breaker auxiliary contact, then we've got 4DD1, and then we've got 4DE3, and then we've got 4DE2. So we've got 4DD1. I think we did create 3BD5. Okay, so we've got 3BD5. So 3BD5 gives us another contact group which is normally open. Okay, which is normally open. So I've got the 3BD5. Okay, and then we're talking about 4DE3 and 4DE2. 4DE5, 4DE3 and 4DE2. So we haven't yet created 4DE3 and 4DE2 as coils, so we're going to create 4DE3 with a normally open auxiliary contact. Okay, so this is 4DE3. So this is our 4DE3. Okay, so we've got our 4DE3. Then we also need our 4DE2. Okay, so we also need our 4DE2. We need our 4DE2, and of course we need a normally open auxiliary contact of 4DE2. Okay, so that's what we need. So the only thing we need to do is come all the way down. We've got a fault reset. Okay, let's just deal with the conditions on the top end. So in this run, we've got what we're calling a fault reset. This is basically similar to a system stop. Okay, it's similar to this push button. Okay, similar to this push button. So this one here is going to be called the fault reset. Okay, it's going to be called the fault reset in this position. Okay, and then of course we already have 4DD1 as a coil, so 4DD1 is there, and then we've got an indicator lamp, okay, which is designation 4DH1 as a fault indicator, right? So as a fault indicator, that should be under others. Okay, nope, is it? Black box. Let's see. Relay core signaling devices. Okay, well, we've got the lamp. Okay, so transformation, rotate right, and then this one here is being called 4DH1. Okay, 4DH1. Do you know? Not accessories, but it's going to be called 4DH1. This is 4DH1, and the color is it's a fault trip auxiliary relay. So the kind of current is AC. Operational voltage is okay. To operate, it's got like a valid. Okay, it's going to operate 420 volts, though it's got a varied operational range. So that's 4DH1. So this is our 4DH1. This is 4DH1. So we've finished this part. Okay, we've got everything we need. So let's see. Okay, so what we're saying was in the first run, what we need is what? MC. Okay, so we're going to come from MC, auxiliary contact of the main circuit breaker or main isolator, and then thereafter we've got this parallel branch leading to 4DD1, of which we have everything we need. Okay, we have things like 4DE3. We have, don't want to be doing this as individual. Okay, so this transformation, rotate left, so having transformed these, we just need to connect these in parallel. So these need to be right after the MC. Okay, so this one will come here. Let's move these a little bit in this position. Okay, let's say then thereafter down here we've got the fault reset. Okay, so we've got the fault reset. Should I align this to this? Okay, we've got the fault reset, and then we've got 4DD1. Okay, so we get to pick our 4DD1. We need this 4DD1, and then this transformation, rotate left. Okay, so 4DD1 comes with a comment, which is fault trip auxiliary relay. Okay, So this is our fourth strip. This is our fourth strip auxiliary relay. Okay, that's what that is. Then this is in this position. Okay, so let's see, we have enough space here. Okay, but I'll need to align this one and this relay. I need to align them bottom. Okay, alignment bottom. Then thereafter I can just simply, okay, apart from that, okay, I need to align this one and this control relay alignment middle. Don't really think this is going to be what we expect, so maybe we need to just do that. So that now we link this part here, and then we just so let's see. Okay, that works out. Then maybe unlock the connection port names. So let's see. Lock connection port names, unlock connection port names. Okay, so then of course on this end, the only thing we need to do is let's do this. Okay, then on this other end, could we get away with jumpers? Okay, then maybe push it out a bit. So I've done this, so the only thing that we need to do is what? Is worry about this other end. So we're coming from this end, so the main circuit breaker, auxiliary contact, and then what do we have? We have 4DD1 auxiliary contact. Okay, so 4DD1 should give us an auxiliary contact, which is normally closed, right? So create another group and get a normally closed contact. Okay, and then this one here, transformation, rotate left, that is 4DD1, this one here, and then 3BD6, we need a normally open auxiliary contact. So from 3BD6, create a group, get a normally open contact. Okay, now 3BD6 has to be normally open. You use it as a normally open contact because it was a safety relay. Okay, this was a safety relay which is always constantly energized under normal conditions. So if we use a normally open contact in this position in rang 10, then if under a healthy state, this should be closed because 3BD6 as a control relay is always constantly energized. Okay, so let's go again here. 4DD1, then 3BD6 transformation, rotate left. So this is our 3BD6, and then thereafter we may need to, maybe, I don't know, we may need to do this. So 4DD1, do I move it a little bit to the left? Maybe. Okay. Okay, maybe like this. Okay. So we have MC 4DD1, we have 3BD6, and then thereafter we need a 3-position selector switch, okay, which is in this position. This is like a 3-position selector switch, normal, off, and test. Okay, so for that particular case, we need to come under multi-position switches. Okay, so under multi-position switches we have switch position, 2 positions, no, 3 positions. Yes, we need this 3-position switch. Transformation, rotate right. Okay, we just need to know that position 3 is normal. Okay, position 3 is normal. Okay, position 3 is supposed to be normal. Okay, and then of course maybe we go with times. Okay, we go with Times New Roman. Allows us to go size smaller. Up, size up. Okay, this is okay. So in this side we have normal selection, right? And then in position 1 we're going to have test position. Okay, let's see, what am I worried about? So when it's starting, it will reset to position 1. So position 2, position 3. Okay, position 2, position 1. So what we want is when we're starting, there shouldn't be a position selected. Okay, we first deal with the normal position, which is in this case is going to be position 3, and then of course in position 3 what we want to happen is we'll have this thing like what is being referred to as a clutch timer. Now a clutch timer is essentially just an off delay timer. Okay, it allows you to delay the de-energizing of the lubrication pump. So that said, we're talking about a relay coil of a slow releasing relay. So this is what we want. Okay, it's essentially an off delay timer. What I mean by that is I'm going to borrow this again. I'm going to borrow this so that I show you. Okay, if we have an associated normally open contact, Okay, if we have an associated normally open contact like so, then of course for the coil, okay, what I'm saying is this is going to be called 4DD3, okay, clash timer, but the targeted coil is 4DD3, or we can even call it a clash timer, but I'm going to designate this as 4DD3, but we have a coil designation 4DD3 already created, so so we need 4DD3, right? So this coil as an off delay timer, but we just think of it as an off delay timer. So this is going to be 4DD3. Okay. So this is our 4DD3, which is this particular coil, okay, in this schematic. So what's going to happen is this, okay, transformation, rotate left, okay, and then the associated coil contact is that one, and then we've got this push button like so. We need this, we need that part, and then don't worry about it. This is just purely for illustrative purposes. It's not a permanent situation, okay? So it doesn't really need to be perfect. So we're going to simulate. We've forgotten to set the time value, which we're going to set for 5, okay? Maximum delay on release is it's 10 milliseconds, then the set value is 5 seconds, okay? So upon simulation, we expect this contact to instantly close like so. But when you open this position, there should be a delay of, like, ideally it should be 5 seconds, but what we're getting is like maybe 10 or 13. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, okay? So I don't know whether this is just the software itself or something else, but that's way too much time to wait, okay? So I'm going to be liberal with the time setting. All I need is a delayed to open effect, okay? That's all I need. So I've put 1 second, see what we get, okay? So let's see. Again, close this position, instantly close, open this, 1, 2, 3, 4, 5, okay, right about 5 seconds. So a second gives me 5 seconds. So that's the behavior that we were getting. So you notice that this is a delay to open, okay, delay to release. So I'm going to do what? I'm going to delete this because we've shown what it is we're trying to achieve, okay? This behavior is going to cover the behavior that 4DD3 exhibits, okay? But at the same time, you notice that right after the multi-position selector switch, the 3-position selector switch, there's 3BD 3BD2, right? 3BD2 is there, and then we need a normally open contact of 3BD2, builder, other group, normally open contact. Okay. So this is our 3BD2. Transformation, rotate left. So I think we need this one here, this one here, this one here. Unlock the connection port names. So transformation 180. Okay, so it's associated with 3BD2, and then I need to make some edits with the connection port names. Okay, it's not necessary, but I just need them not to be so close to the contact itself. Okay. This is okay. So what we need to do now is link this up. Okay, so we're going to have MC. Right after that, we've got this parallel configuration. So essentially, we need to connect this to the live end of the control. Then we need to link this. Again, I'll need this one, this one, this one here, and this one here. I need to align in the middle. Okay, so that now we have them perfectly aligned. And then this, okay, we can move it a little bit down because it's going to come like this. Okay, and then link this up. So I've got 4DD1, we've got 3BD6. Then right after that, we've got the 3-position selector switch, but our interest is in this position 3, which we are going to link to 3BD2. Okay, maybe let's move it a little bit down, like so. Now okay, we're going to have it like so. So we have the 3BD2, which is this 3BD2 targeting to control 4DD3. So 4DD3 is there. We just need to link this, and then we need to align this coil to this other one. So alignment bottom. Okay, bottom align. But I need to, like so. So this is our 4DD3. So what we're saying is the effect we're going for is to delay the operation of or rather the de-energization of the lubrication pump. Okay, so once 3BD2 times out, or rather is energized, then 4DD3 is going to be energized instantly. It's associated normally open contact is going to close, and then thereafter when we switch off, it's going to have a delayed stop. Okay, so that's the operation that we're going for. And then you notice that across from 3BD2 there's actually 284. Okay, so I don't really think we have created 284 as a control relay. Okay, because 284 should be the control relay associated with the test mode for the main drive. So 284, we're yet to create 284, so we're going to take the liberty of creating 284. Okay. No, but 284 has to be a control relay and not a power contactor. Okay, so it needs to be a control relay. So this is going to be designation 284. Okay, so this is going to be 284, of which we need to get a normally open auxiliary contact. Okay, we need to get a normally open auxiliary contact of 284, and then this contact is expected to be right across from 3BD2. Okay, so this one here, transformation, rotate left, like this, and then of course I need to stretch out the port names. Like so. And then we're saying 284 is right across from 3BD2. So 284 is right across from 3BD2. So we're going to have this one here, like here. So this is what we have. Okay, so essentially this doesn't look nice. So can I maybe move this a bit down? Can I move this and this one here? Need to move them maybe center line. Okay, this looks better. So we have 284 right across from 3BD2, which is this one here. Okay, targeting the control of 4DD3. So what we're saying is the instant 3BD2 times out is going to energize the control relay 4DD3. Okay, now 4DD3 is going to instantly close its associated normally open auxiliary contact like we just showed. And then at the point of switching off, it's going to delay the operation of this by a preset value. Okay, so this, we've taken care of whatever this is. Okay, so this has taken the position of the clutch timer. So I don't know if we can maybe put a comment. Control relay, this is there. Yes, here. So essentially what we're just saying is this is going to be the clutch timer. Okay, as it were in the circuit. Okay, so this position now is the clutch timer. Same operation, no concern. Delay the de-energization of the lubrication pump, which is what the same effect we're going to get from this. Okay, so we've taken care of this part here. Okay, then thereafter we're saying that we need a normally open contact, auxiliary contact of 4DD3, which is this one here. Okay, so transformation, rotate left, and then of course my same issue with the port names. Okay, need to move them away a bit from the contact. So when this is done, I can maybe align it here, right? So this is 4DD3, and it needs to come right after the normal position. Like in this path, it needs to come here. So this needs to be just linked to this position. Okay, Then we can stretch this out a bit. And then when this is done, the other end of this is just 4DC1, and I think we have created 4DC1 as a coil, or we did create 4DC1 as a coil. Oh, I thought we did. I know we did, because this is at the same time. Here. No, I knew we did create the. So this position is 4DC1. So transformation, rotate left. We need to bring it here. So maybe I need to link it to the power, to the neutral path. Okay. And then of course I just do this. Okay. So we've taken care of the control of 4DC1, which is the lubrication pump. Perhaps we need to do our comment. Okay. And then we're going to say this is the lubrication pump. Okay. That is a lubrication pump. So this right here is the lubrication pump. So I've done the control of the lubrication pump along the path for normal operation. Okay. Now in this other position, what are we saying? What we're saying is the 4DC1 energizes this path. This has to be in the normal mode. Okay. So perhaps would want to move to say 4DC1 as the normally open auxiliary contact is going to control 4DD2. So have we created 4DD2? Yes, this is 4DD2. So I just want to switch the positions of these two. Okay. It won't change anything from the way it's been created, but I would rather everything is just sequential. Okay. So we're going to get this one here as 4DD2. Okay. And then we're saying that 4DD2 is controlled by the normally open auxiliary contact of 4DC1. Okay. So 4DC1 needs to give us a normally open auxiliary contact. Okay. Which is normally open auxiliary contact. Okay. Anyway, I don't know why it keeps doing this. Okay. So transformation, rotate left, and then the same thing with the port names. Okay. We need to move it out a bit. So like this. So link this here, and then link this there. Okay. And then of course this is 4DC1. We know that this is 4DC1. So this is 4DC1. Like so. So the normally open auxiliary contact of 4DC1, which is the power contactor for controlling the lubrication pump, is normally open auxiliary contact, is the one which controls the main drive delay timer. So 4DD2, this 4DD2 is the main drive delay timer. Okay. The comment is main drive. Is the main drive delay timer. Okay. So this right here is the main drive delay timer. This timer 4DD2 is the main drive delay timer, which is this one. Now the reason why I've done it like this is because in the normal position of the multi-position selector switch, it's this path here, okay, as well as this other path. Okay. Now in the test position, which is position 2, in our case, we're going to target just the we're just going to target the push button, right? So this is going to be similar to a start push button. Okay, so what we're going to do is we're just going to copy the start. Okay, we're going to copy the start. So we're going to copy the start to the test position. Okay, like so, and then this we're going to call the test mode loop pump motor. Okay, that's what it's called. So us, we're just going to call this lubrication pump test. Okay, or rather test dash PB, which is push button. Okay, we're going to have it like so, which is what this push button is. Okay, and then we're saying that it takes after it's essentially just a test position, but because it comes after 3BD6, we come to this position, test position 2, and then we just come up here like so. Okay, come like that, and then it loops after 4DC1. Okay, it loops after, is it 4DC1? It loops after what am I doing? This is 4DD2, 4DC1. Okay, so it's trying to control 4DC1. So 4DC1 is the targeted control of this, but I don't want to have these crossing lines. So what I'm starting to think is it might have been a good idea to do the following. Okay, I'm not changing anything, I'm just rearranging to avoid crossing lines. Okay, so I may want to maybe move this out like so, and then I may want to also move this out and put this in this position like so, and then this one here comes here. Okay, so 4DD2 is the main drive delay timer. Then maybe let me just do this. So this one's clutch timer, main drive delay timer, lubrication pump. Okay, so maybe this transformation, rotate left, need to put this here. Worry about you later. Okay, so 4DD3 then like so, and then we loop this like so. Okay, I think this is just about it. After the test position, after the normal position, you have 3 parallel branches. Okay, so let me move this out a bit like so. Same thing with this other one here. Okay, And the whole point of me doing this is because the test mode loop pump motor, this push button is targeting the control of 4DC1, so it's the only thing I've done. Okay. So this is what we have. Okay. And then 4DD1 4th strip auxiliary relay, okay, for the loop pump. Okay. Okay, so test was position 2, so this test is actually for this position. Okay. So I'm going to put it on this path. Okay. Okay, so I think that's just about it. So we've got 284 right across from 3BD2. So 284 right across from 3BD2, trying to control 4DD3. Okay. And again, my concern was on this one here, because I'm not seeing the release. Okay. Okay. So this one, transformation, rotate left. So this preset value is for here. Okay. Then this one is for 4DD2, like this. So in the normal path, we've got 284 right across from 3BD4. So 284 right across from 3BD2. And then the other path in the normal mode will be that targeting 4DC1, okay, which is this targeting 4DC1. Then the other one had to do with the control of the main drive delay timer, interlock for 4DC1. So 4DC1 controlled 4DD2, which is this one here. And then 4DC1, which is the loop pump control power contactor, was controlled by way of the clutch timer normally open auxiliary contact, but again is being controlled by way of the test mode push button here, okay, which is now coming through the test position. Okay, so this is really taken care of. Then going to the right, there's really nothing much there, because we did take care of 4DD1. The only one thing we need to do is the 4DH1. So 4DH1 is right across from 4DD1. So 4DH1 is right across from 4DD1. So just need to connect these 2 points. This one and this here. Alignment, align bottom. Okay. Then this is right across from 4DD1, so I can just as well connect it there. This takes care of this, and then thereafter we've got the lube oil pump running, okay, which also has been controlled by 4DC1. Okay, so 4DC1 needs to have an auxiliary contact. Okay, 4DC1 needs to have a normally open auxiliary contact. I hope it won't change the associated names. Okay, this time it doesn't, so this seems to have an attitude. So this is 4DC1, like so, and then unlock the port, connection port names, and then of course we transform this. Transformation, rotate left. So this is 4DC1, so apparently, okay, so it's like that. So 4DC1 as a feedback is going to have this indicator lamp, which is loop oil pump running. Okay, so we can just as well copy this, change the designation or the color to green to indicate that it's running, and then builder item identifier is 4DH2. Okay, this is going to be 4DH2. So this is our 4DH2, and the comment is loop pump on. Okay, do we have a comment section? Loop pump, component identification, color, voltage. So no comment for this one. Oh well. So this is 4DH1, then 4DH2, which is going to be powered by way of 4DC1. Okay, so I'm going to just align it to these other contacts, because 4DC1, okay, maybe this one here. Okay, no bother. Going to connect it there. Then this other end connects to the lamp. Okay, apparently this one and this one, rather I need to select this first, select this other one, then alignment, middle align. Okay, okay, then this other end connects to the neutral, like so. And then when this is done, I think this takes care of the loop oil pump running. Okay, so the only thing we've done is we've done most of what needs to be done. Okay, then thereafter we'll go to the next page. Okay, because I know this is the extreme end of this, but the next page also has some components to do with the lubrication. 3BD3 as a control relay was created. Okay, so 3BD3 is this one here. Okay, so transformation, rotate left. So this is our 3BD3. I don't know if I can maybe just zoom in a little bit more. Okay, so this is our 3BD3. So our 3BD3 is being controlled by the loop oil temperature switch. Okay, so maybe we can just as well insert a comment. So we're going to call this as lubrication temperature. Okay, so that's what this control relay is for. Okay, because it's been controlled by the loop oil temperature switch. Now we don't have a switch, so in this particular regard we just borrow one of those emergency push buttons, okay, to hold the position of the loop oil temperature switch. Okay, so we go to the right. So what we're saying is now this is going to hold the position for the loop oil temperature switch. So this is item identifier. We're going to say temperature switch. Ideally, this is supposed to come from a temperature controller, but we don't have that, and we need for our circuit to work. So that's why we're going to just use a manually activated switch like this one. Okay, so transformation, rotate left. So this is a temperature switch, which again I'm saying should come from a temperature controller, a normally closed auxiliary contact of your temperature controller, which opens when the temperature exceeds a preset value. But we don't have that, so this position, this is what we're using. So this and this alignment, middle. Okay. No, apparently middle doesn't do it for us. Okay, so we need to connect this point to this other point, but we need to align this and this, then alignment bottom align. Okay, so that we are able to connect them properly. Then this other end is just connected to this position. The next rung is a 3BD3. Okay, 3BD3 needs an auxiliary contact of, or rather this 3BD3 is an auxiliary contact of this. Okay, so in as much as okay, we could have connected it right across from the coil, but we'll borrow an auxiliary contact, okay, which is normally open. They're saying it's normally closed, so contact group normally closed. Okay, so we get this transformation. First unlock this transformation, rotate left. So this is 3BD3 associated normally closed contact. Okay, and the reason it's normally closed, because here it's saying loop, where is that? 3BD3 for 3BH1 it says loop oil temperature high indicator. Okay, so when this lamp comes on, it shows that the lubrication oil temperature is high. Okay, nombapa twalabula iyi. Okay, because ngana mumona apa iyi iri mu closed position, so 3BD3 is always constantly energized, and then if it's de-energized, it means that the temperature is high. Okay, so we get this 3BD3, maybe align it in that position. What do we have? Or maybe I'll just take it up here, so that now this 3BD3 will be responsible for an indicator lamp designation 3BH1. So we'll copy this, and then we'll call this indicator lamp. Okay, it needs to be red because it's a fault condition, and then it will be 3BH1. Okay, it will be 3BH1. Then this one and this here will be aligned centrally, middle. Okay, align middle, so that now this is connected there. We connect here, then we connect there. Okay, so that takes care of 3BH1. 3BH1. Then thereafter we are talking about the lubrication or flow switch, okay, which will control 3BD4. So we did create 3BD4, which is this one here. Transformation, rotate left, like so. So this one and this one here, alignment bottom align. Okay, but the conditions, okay, again the conditions, you're talking about the loop overflow switch 1, loop overflow switch 2. We do not have the required flow switches. So what we're going to do is, we know that the flow is a consequence of 4DC1. This is the power contactor which is being controlled to power the power contactor. Okay, so what we're going to do is, we're going to borrow, or rather create a normally open contact group. Okay, normally open contact group. So close that, and then we do that. Then we borrow this normally open auxiliary contact to help us simulate the the existence of flow. Okay, and then what we're going to do is, maybe I'm just going to put it right here. Okay, transformation, rotate left. Again, I need to emphasize that this what we're doing is not part of the original circuit. The reason why this is even an issue is because Tatukwete, we don't have the flow switches, and we will need to simulate this circuit. So I'm just trying to create conditions that will allow us to simulate the flow without the hardware. Okay, so for DC1, we need 4 DC1, and then we need a single phase source. Okay, so under electrotechnical NEMA, we need to come to where it says control power. We need to come to where it says power, energy sources, single phase source. We need this source. Okay, it's conveniently 120 volts, or rather AC, 120 volts AC. So I'm going to link it to this point, and then of course I'm going to need can I align this and this? Alignment middle. Oh, anyway, no biggie. Okay, so this is what we have. Transformation, rotate left, transformation, rotate left. Again, I'm only doing this because of the need to simulate, not that this was needed, no. So now that we have the auxiliary contact connection point, is it unlocked? Okay, it's good. And then I need a coil. Okay, I need a control relay. Under relay coils, I need a 120 volt AC coil. Okay, transformation, rotate left, and then this I'm going to call flow 1. Okay, I'm going to call this as flow 1. I'm going to call this as flow 1. Okay, and then I'll need for this to have a normally open contact group. Okay, need for this to have a normally open contact group. What voltage is this rated for anyway? This is contact 600 contact rated operational voltage, so I don't need to change this. Okay, so transformation, rotate left. Okay, so this is flow 1 simulation. Okay, which has its associated normally open contact. Okay, similarly we'll need this copied. Okay, and then this one here is going to be called flow 2. Okay, and again we need a normally open auxiliary contact. Okay, like so. And this is flow 2, right? And then transformation. Okay, this needs to be in this position also. Needs to be in that position. And then this now gives us these two contacts, flow 1 and flow 2. So that now we have a way of obtaining the necessary conditions: loop overflow switch 1, loop overflow switch 2 to control 3BD4. This is our 3BD4, or maybe I can move it a little bit to the right to get some more space. Okay, so that now this one and this one transformation, rotate left. Okay, so one of these is flow 1, the other one is flow 2. So this is our flow 1, then the other one is flow switch 2. Okay. Transformation, rotate left, transformation, rotate left again, then this and this. I need to unlock the connection port names so that I move these out a bit. Okay, so when this is done, maybe move a bit to the right again, and then I need for this one, and this one to align in the middle section. So align middle. 281 is not an issue now first. Okay, so we have 3BD4, we have got flow switch 2, we've got flow switch 1 all the way to the live end of the control. Okay, so we just need to link this to this one here, link this one to that position, and then we need to connect this all the way to the live end of the control. Okay, so now the way this is going to work, okay, and the reason we needed this single phase source is so we get to control these coils. Okay, but later we may also need to simulate the failure of flow. Okay, so which is why we'll borrow the stop push button. Okay, or rather we can just borrow the let's see, under switches. Okay, so control switches, push button switch with break contact, automatic return. I need a push button switch with break contact. No automatic return. No. Push button switch with break contact, automatic return. Push button mushroom. Anyway, might as well use the same one because I was hoping there could have been the so we use it in that position. So this is just to help us simulate the flow. Make contact. No, we need break contact. This is the one we need. Okay, not this guy. Transformation, rotate left. This is just to help us simulate the failure of flow. Okay, so I'm going to copy this like so, and then all we need to do is this. Okay, Okay, so we just need to link this like so. Okay, so this addition here is not part of the original schematic, but it's just so we simulate the availability of flow. Okay, now the reason why 4DC1 is used as a condition for the flow is because 4DC1 in this position we're taking the auxiliary contact of the power contactor for the lubrication pump. So when the lubrication pump power contactor is energized, the expectation is that the lubrication pump is going to run. Okay, and then because the lubrication pump is running, there should be a resultant flow as a consequence of the pump running. Okay, and then thereafter, that's why we're using the feedback contact to energize these two control relays. Okay, which have associated normally open contacts. Okay, so basically this is just flow simulation. Okay, so we have that taking care of this path, and then lubrication of flow stopped indicator. So we're talking about 3BD5. So 3BD5 I feel was created already. Okay, so we just need to go to 3BD5. We need to find where 3BD5 is. Oh, it wasn't created, but do we have 3BD5 as a relay, a control relay? So this is 3BD5. Okay, so this is our 3BD5, and then of course we're saying that 3BD5 auxiliary contact is the lubrication of flow stopped indicator. I'm just going to swap these two positions. Okay, so what we're going to do is we're going to focus on 3BD5. So 3BD5 needs 4DD2 and it needs a reset. Okay, so what we're going to do is going to do this. Alignment middle. Okay, so I just move them all to the right. Okay, so what we need is a reset. Okay, so push button switch with brake contact, automatic return. We need this one here, and then this we're going to call a reset. I feel this is essentially just a reset. Okay, so here data item identifier, we're going to call this as just reset. Okay, so we have this reset, then transformation, rotate left, now if we do not want to do this, okay, if we do not want to do this, there's I think we had another fault reset. We had this. Okay, builder, can we associate a contact? Okay, so we're going to associate normally. No, we need another group. We need to associate we can go with this one. Okay, okay, so if we do fault reset, just a singular fault reset in the system. Okay, so that we're not moving back and forth, oh reset this, oh this and that. We just have a single reset. So we're going to take this to this position. Okay, so which is to say we don't need this guy, so delete this. So we're saying there's a reset, then there's a normally open contact associated with 4DD2. Okay, so 4DD2 has already been used. So let's see, 4DD2 we need a normally open contact. We need to create a contact group and then get ourselves a normally open contact. Okay, so this now is our 4DD2. So we're saying 4DD2 transformation, rotate left. Okay, put this one there, maybe align it to this other one. Okay, then okay, so the reset. Okay, this is our reset, followed by 4DD2, and then we need a normally close contact from 3BD4. Okay, we need a normally close contact of 3BD4. So create another group, get yourself a normally close contact. Okay, so transformation, rotate left. So this comes here, unlock the connection port names, drag them out a bit, so that now we have 3BD4, we have 4DD2, we have 3BD5 is an associative contact, okay, of 3BD5 control relay. So we'll come here, but first we need to align this one and this control relay, alignment mode bottom align. Okay, so when this is done, we then need to create a ceiling contact. So create a contact group which is normally open. Okay, of which we're going to transform, rotate left like so, move this here, and this is going to be right across from 4DD2. Then connection port names, unlock. Come on, move it out a bit. You may need to do the same thing with this one here, like that. So 4DD2 right across from 3BD5, then thereafter 3BD4, and then we've got a reset on the opposite end. So we need this one, this one, this one, and this here to be aligned in the middle position. Okay, so that now we only need to have them then thereafter just link them up. It's not mission critical, but I would rather this and this. Align middle. Okay, alignment middle. Okay, I can live with this. Okay, so I can just connect this point. So that takes care of one end of 3BD5 linked to 3BD4. Okay, then thereafter linked to 4DD2, which is this one here, which is right across from 3BD5. Okay, which is right across from 3BD5, which is here, going to the reset, and then this path is complete. Okay, so we're going to go for 3BH2, which is controlled by the auxiliary open contact, normally open contact of 3BD5. So 3BD5 needs to give us a normally open contact group. Okay, so which is normally open like that. So 3BD5 transformation, rotate left. Again, I just need to unlock the connection port name. Then okay, I don't need to move this port name a little bit out. So this we can put maybe here. And all this because we need an indicator lamp designation 3BH2, which is saying loop overflow stopped. So we need an indicator lamp. So this, we need to copy to this position. Okay. So this is 3BH2. So this is going to be our 3BH2. 3BH. This is going to be our 3BH2. And then loop overflow stopped. So I take it needs to also be red. So that's why I haven't changed the indicative color. Okay. So this one needs to be linked now to this and this. I need to align middle. Okay. And then I can just connect this point to this point. Then connect this point to this here point. And then this point to the neutral end. Okay. Because before I do that, I need to align this one. This control relay to 3BH2. Alignment bottom, align. And then I just need to link this. Okay. So 3BH2 is the loop overflow stopped. Okay. 3BH2, but can I copy? I can copy maybe this one here. Okay. Control C, and then Control V. So I was saying this is what? So loop overflow stopped, loop overflow stopped indicator. Okay, which is what this indicator lamp is for. Okay, so maybe let me just stretch it down a bit. Indicator. Can't even spell indicator. Let's say loop overflow stopped indicator. Okay, loop overflow stopped indicator, which is this 3BH2, and then 3BH1 was the loop oil temperature high indicator. Okay, so loop oil temperature, loop oil temperature, high indicator. Okay, so this 3BH1 was the loop oil temperature high indicator, then this other one is loop oil flow stopped indicator. The loop oil filter bypass switch, we do not have this switch. Okay, and we need it to be normally open. Okay, so what we need is make contact. So we can get this one here, emergency stop push button with a make contact, and then we transformation, rotate left, because we do not have this switch. So if we needed to ever simulate this, we can just get this type of push button. Okay, and then of course it's going to be coupled to an indicator lamp. And then this is 3BH3. So this is going to be 3BH3, and then the comment lube oil filter, lube oil filter blocked. Lube oil filter blocked indicator. That's 3BH3. Lube oil filter. Okay, so lube oil filter blocked indicator. So we can just link this to the neutral end, the other end to our simulated switch. Okay, because we do not have the hardware to simulate this, but this is going to help us simulate everything. Okay, like so. So this is done. We've done this lube oil filter. So I just need to copy this lube oil filter bypass switch. Okay, lube oil filter bypass switch, like this. This is a lube oil filter bypass switch, which is this one here. So I think in as far as the lubrication pump is concerned, this is the end of that. So this circuit would probably look something like this. Okay, I know it's huge, but it is what it is. So these control relay coils and power conductor coils, they are not part of this schematic, so maybe we may want to move them to another one. Okay, so maybe control circuit, so rename this. So this is clearly the lubrication pump control circuit. Okay, no spaces, I get that. Okay, so underscore. Okay, then thereafter we need to move whatever relay, or rather whatever coil we haven't used. We're going to insert another diagram. Okay, so new electrotechnical diagram, default, yes, and then this one, anyway, rename. I don't want to rename anything, I just need to copy this. Okay, Control C, but I'm going to rename this to the crusher main drive. Okay, crusher main drive control circuit. Oh, come on. We need to move all those coils that we haven't used to this schematic. Okay, as in we needed to move all of these to this document. Okay, so which is why we needed these elements to be moved. So let's see. So our circuit is probably going to look something like this. So let's save this and look at what we have. Okay, so let's just have a quick looky. Okay, so let's see if this is closed. Low bore temperature, high indicator. Why are you not energized? Okay, low bore temperature, high indicator. This can't be good. The control voltage is rated voltage is 120 volts. Okay, and then just flickers, and then this line is okay. Low bore temperature. Anyway, I understand. This is normally closed, so it opens, so the lamp is not supposed to come on. Then low bore temperature, lubrication temperature. So this is supposed to be energized. So 3BD3 is energized. So let's see. If we start from the left, so we don't have the hydrosetters at yet, so that's why it's open. That's why 3BD6 is open. Okay, but if we wanted to simulate, okay, if we wanted to see if our circuit is working okay, okay, let's see what else would stop us from simulating this. Okay, so 3BD5 is not operated, so we come down. Once 3BD6 is energized, then we will need 4DD1. We need for 4DD1 to be energized, so the 4DD1 is this one here. Okay, and right now 4DD1 is not energized, which implies that in this position we need 4DD1 to be used as a normally closed contact and not open. Okay, because 4DD1 is only energized under fault conditions. Okay, so we have that. So the only thing we need to worry about is 3BD6. Okay, so 3BD6 will take care of 3BD6 by temporarily removing the control, the interruption from the hydroset. So we go to the right. I think apart from that, nothing can stop the lubrication pump from running. Okay, so what I'm going to do is, for now, just for test purposes, I would remove this contact. Okay, I'm going to put it back, but for now I'm just going to get rid of it so that we simulate the circuit. We see how the circuit is going to work. Okay, that's done. So let's simulate. Okay, so when simulating, we start from the left side where we're saying the safety relay is healthy, and then in the second run we notice that there's continuity all the way up to the start, so meaning the sequence control relay can be energized. So in this particular path, we'll notice that the one thing that we would need is we need to select the, okay, in this path. So when the sequence control relay is energized, the alarms would come on. Then in this other path, would need to change to select the operational state. So we need to be in the normal mode, okay? And then we're in the normal mode. When we're in this normal mode, meaning when 3BD2 is energized, then this the clutch timer representation 4DD3 would close. It would close there, and the lubrication pump would start. Okay, I think that's the only thing we can test. Okay, the only problem we had was with the presetting the values for the timers. Okay, that's the only challenge we had. Okay, but other than that we should be able to start. Okay, so what we expect to happen is let me maybe just try to move. Let me just try to do this, and then okay, so what we expect to happen is if we press the system start, okay, momentarily we'll seal in, then the alarms come on. Okay, the remote station alarm come on. Okay, we needed to pick. Okay, and then at some point 3BD2 is going to time out, and then when it times out, it energizes 4DD3. Okay, so when 4DD3 is energized, it's the one which energizes the lubrication pump by way of the power conductor designation 4DC1. Okay, so like that. Okay, so we have this sequence of events, and then the only bit of interest is that when we do press the system stop, okay, press the system stop, sequence control relay is de-energized, but the lubrication pump continues running for a preset time, and then thereafter it's de-energized. Okay, so that's the behavior that we were looking for. Let's look at that once more. Okay, so let's look at this once more time. So the sequence starts. Okay, we need to select this, okay, so that we energize 4DC1. So when 4DC1 is energized, we expect a simulated flow, in which case we won't have to look at this section. There's nothing interesting going on the left side, so maybe we can look at it from the right side point of view. Okay, so what we're saying is when we simulate a failure of flow, okay, so main drive delay time, so only when this is energized and there's no flow. Okay, so when it's like this and there's simulate a flow failure, okay, so everything just powers down. Okay, so when you simulate a flow, everything just powers down. Okay, let's do a reset. Okay, normalize the flow simulation. do a system reset. Then start the system. And just wait. Okay. So maybe the one thing that we don't have to look at is, okay, so let's see. At some point the lubrication pump will start running, and then in this branch what we're saying is, at the point where the main drive delay timer is energized, okay, at the point where this is energized, if there's no confirmed flow, then the system just powers down. Okay, so it only becomes an issue when the main drive delay timer is energized. Okay, when this position, when 4DD2 is energized. Okay, so we're waiting for 4DD2 to be energized, like so. So at this point, if there's a failure of the flow, look at what happens to the lubrication pump. So a simulated failure of the flow. The lubrication pump is powered down, okay? And then of course 4DH1 is loop or flow stopped. This is a loop of, or a lubrication pump fault, okay? So if we go to the right, what we do get is the loop oil flow stopped indicator. Okay, this is what we get as the cause of this whole powering down of the system. Okay, so normalize this, and I bet this is where we stop with the simulating the flow. Okay, but just as well we did skim over this, so I don't think this is needed. Okay, so what we need to do is need to say view. We need to move this coil to this page. Okay, so I bet this is the only thing we need to do with the lubrication control circuit. So the only other thing that we'll come and look at is the main drive. Okay, we'll come and look at the crusher main drive control, which is not really that huge. Okay, it's a very small circuit. I think it's a very small circuit. This is all there is for the crusher main drive. It shouldn't take a long time. Okay, the lubrication system is by far the largest circuit of all of them. Okay, cheers.